You can stop me in the middle if something is not clear. Open shortest path first. This routing protocol is widely seen both in enterprises as well as in the service provider network. The good reason why OSPF is very popular, it is link state routing protocol. The link state, the status of the link is advertised by every router. When we say status of the link, it includes the IP address, the mask, the bandwidth, dynamically calculated cost. OSPF metric is cost. And few more things. So every link that is up in state, which is included in the process of OSPF, the status of those links will be advertised using a multicast address. After forming neighbor. So advertisement is not before forming neighbor. To form neighbor, OSPF uses hello packets. These hello packets are sent every 10 seconds. Using the same multicast address, the hello packets are sent every 10 seconds. And most of the time updates are sent. Using 224.0.0.5. What does it mean? Sometime there will be even unicast updates. After knowing the neighbor for the first time, you can see multicast involved in distributing the update. But after forming neighbor, there may be a query for one neighbor. Not every neighbor queries. There is one query from one particular neighbor. So the reply to the query is also an update. LSU, link state update. Link state request, link state update, reply, LSR. Collection of LSA is what LSU. Collection of LSA is LSU, link state update. Anyway, so updates are not only sent using multicast address, it is also used. The unicast address is also used. Hello packets helps to discover the neighbor. Every router that has got OSPF will be tuned to receive those multicast feeds that coming from various neighbors to the address 224.0.0.5. Listen, I'm repeating. All router uses 224.0.0.5 to send a hello. Every other router which runs OSPF will be listening to that address 224.0.0.5 So only they receive the hello packet, no other routers. The RIP enabled router cannot receive OSPF hello packets because the RIP is tuned to 224.0.0.9 version 2 RIP. So only OSPF routers will accept the hello packet and process the hello packet. And if some parameters like area ID, I'll talk about it if you don't know, area ID, the hello timers, authentication type and authentication string if enabled, stub type if enabled. When these things matches, they form neighbor. So if you see here, this routing protocol has got dynamic discovery of neighbor feature, which was not there in BGP. And the updates are sent using multicast so that you no need to send the update to each neighbor as a separate packet. You no need to duplicate the same update multiple times and send it to every other router, which is process as well as bandwidth consuming. So sending using multicast address is good so that everyone will learn from one single packet. No need to duplicate to as many number of neighbor. So multicasting is good, and OSPF uses multicasting. And only when there is a change, the change will be updated again using multicasting. But there are some time where when a query is sent, unicast is also used because every router knows their neighbor. It uses the neighbor's IP address to respond to the unicast and send a query to the upstream. So unicast is also involved in giving and taking the route information. Because it's a link state routing protocol, every router within an area will have complete knowledge of topology. If you take EIGRP, they advertise only the best route. The route that is available in the routing table can only be advertised. Even BGP does the same thing. The route that is available in the routing table only that can be advertised to the neighbor. So if my router advertises route to you, I'm just advertising only the best routes to you. But there are other routes that I know, but I'm not having it in my routing table because it is not best for me. Please understand. When I advertise the routing table to you, I advertise only the best route. So you are not going to learn everything that I know, you are learning partial things. Things that are best for me will be in the routing table, only those things you know. So, see how good is OSPF. OSPF advertises link state of every link on every router. As a result, every router will know about all other routers and their links connected between them, the subnets on them, the shortest paths to reach them. It will have a complete knowledge of topology. Every router will have a complete knowledge of topology, which is not at all possible in EIGRP topology. OSPF topology table will really have a complete picture of the topology. But within an area. Within an area, OSPF will have multiple areas. We'll talk about that if you are new to OSPF a bit later. So what I want to say here is, within an area, every router will have an identical map called topology table. Identical map. This map is discovered as they receive LSAs from other routers. Every router sends the LSA, link state advertisement, after forming neighbor. So you may think like OSPF may consume more bandwidth because it is advertising everything, whereas EIGRP advertises only the best route. EIGRP advertises only the best route, whereas OSPF advertises everything. But really, OSPF consumes very less amount of bandwidth compared to EIGRP update size. OSPF they advertise DBD. When two router forms neighbor, between those neighbors, they only send database description, which is a summary of a big database, which is called as LSDB. So in those days, people used to learn typing in the typing institute. Even I learned when I was a small boy. Not that small, my college days. Even before college days, I was going to a typing institute. Morning, I used to type like 96 is my maximum speed. I did not go more than that. So there, they used to teach something called shorthand. If someone is dictating, if you use a shorthand method, you don't need to write too many things. So number of pages consumed will be less. Number of alphabets that you write on the paper will be less, or the typing that you do. To make a note quickly, shorthand method is very nice. Those media people, they will all use shorthand method to write. I don't know whether today's media people do that, but earlier, when there was no video, everything was documented. So they used to write very in a short. When we read, normal people will not understand the full meaning. But when those people who learn shorthand, when they read, they get the 100% knowledge. Likewise, DBD is a shorthand of LSDB. So the 10-page material can be written in half page by a shorthand known person. 10-page, he can write in half a page, same content, same font size. Half page will convey the 10 pages of message. Likewise, LSDB is a summary of, DBD is a summary of LSDB. Right? So the bandwidth consumed by OSPF update is not really much. One OSPF can understand the DBD of other OSPF route. For you and me, when you type show OSPF database, you may not understand anything there much. To an extent, you will understand, but not in detail. Because it's in a shorthand method. Only OSPF can understand. It is OSPF shorthand. Database description. DBD is what going to be shared between two newly formed neighbor as a update. It won't be big detailed one, it will be DBD summary. But the receiving router will be able to understand 100% of message, but if there is any query, if DBD is not well understood somewhere in some portion of the DBD, they are free to send the link state request, LSR, for which LSU will be sent. Link state update. See, I'm trying to introduce you to these abbreviations like LSU, LSR, DBD, LSA, link state advertisement. See, these things are important in OSPF. If you understand OSPF, ISIS is easy, same like OSPF. Those people who wants to go to that segment routing side of service provider network, they really need OSPF and ISIS in-depth knowledge. If you understand OSPF, you will understand ISIS. So, spending time on OSPF is worth. Like you spend on BGP, you also need to spend time more on OSPF. Now, as I said earlier, this protocol is widely used. One reason we have seen it is a link state routing protocol. The other reason is it uses an algorithm which is an open standard called Dijkstra's algorithm. Dijkstra's algorithm is very famous in various places, like operating system uses Dijkstra's algorithm, Windows operating system, the processor on the chipboard and on the motherboard, they use SPF algorithm. So SPF algorithm is a binary tree algorithm. You might have heard about this in your college days. Which is also called as Dijkstra's algorithm. SPF is shortest path first. The other name for SPF is Dijkstra's algorithm or binary tree algorithm. All three are same: shortest path first, binary tree, Dijkstra's algorithm. All these three means the same thing. This is an open standard protocol. Using this protocol, the routing protocol OSPF is designed. Using SPF algorithm, a routing protocol by RFC is OSPF, open shortest path first. So it's open now because it is RFC standard. It has used the open standard SPF algorithm. The SPF algorithm got the name Dijkstra's algorithm after the man who proposed that algorithm. His name is Dijkstra. If you Google, you will see him with a orange color sweater and white color shirt, white and orange. That's the picture they have in the Google. Dijkstra's picture in Google. Orange sweater, the woolen over the white color shirt with a beard. Dijkstra. So this is lightweight algorithm, binary tree. Definitely you might have seen in college. You might have also done some program using C or C++, the binary tree algorithm. I did when I was in masters. Using the same algorithm is what this routing protocol also finds the shortest path to reach the destinations. So that's another reason why OSPF is popular. Thirdly, this protocol has got no hop count limit. This protocol is designed to, this routing protocol is designed to support a big network like internet. If you add BGP to this, it will be more bigger. But OSPF is also a very big protocol. Even though it is an IGP protocol, even though OSPF is an interior gateway protocol, BGP comes as a glue between the autonomous systems. But in all autonomous system, it is the OSPF the one which rules the network. So OSPF is also the protocol of internet. OSPF is designed to accommodate any number of networks, thousands of networks it can manage. It can run the process for thousands of networks. Still, the router won't get tired because the design is like that. OSPF follows a hierarchical design. It uses a kind of two-tier approach. Like this. I'm not drawing a spaceship. You can have many areas around this backbone area. area 0. Area 0 is a number which is reserved as backbone. Now, in the backbone, you may have many routers. And to connect the other areas, you will have one router which is common to both backbone as well as area 1, 2, 3, 4, 5. See, every area has got a router which is overlapping between the areas, which is helping the areas to overlap. So area 0 may have multiple routers inside, but there is one router here, you see the backbone as well as a non-backbone router. This is neither backbone nor backbone. Sorry, it's both backbone as well as non-backbone area router. It's in the border. We call it as area border router. Why I call it as area border router? This leg of the router is in area 0. The other leg of the router, the other hand of the router, is connecting area 1. We call such router which is in between area 0 and the other area as area border router. So we got area border router, area border router, area border router, area border router. These are all area border routers. And these routers are called as internal routers. Even this is also an internal router. The difference is this is internal to the backbone, this is internal to non-backbone. The backbone area and the non-backbone areas are called as regular areas. Regular area, all the non-backbone, this is a regular area, this is another regular area, another 5 regular areas we have in our picture, and one backbone area. You can also call backbone area with another word called transit area. Transit. Now this structure helps routing protocol OSPF to accommodate any number of networks. How many hops OSPF supports? Unlimited. How many network OSPF supports? Even theoretically, no one will say only 5,000, only 10,000. No, there is nothing like that. Any number of networks. You need to properly design with areas. If you do proper design, OSPF is ready to support any number of networks. Need to put them in a nice area, different area. Frequent talkers, all frequent talkers, put them in one area. The other group of frequent talkers, another area. The other group of frequent talkers, another area. To combine all these, very seldom they talk, very rarely they talk between the areas. You connect them through backbone. In that way, you can keep the packets flying here and there, and keep low the updates and queries flying here and there. You need to put all the frequent talker in one area, the other group of frequent talker in another area. Only when this area and that area want to talk, they will use area 0. Otherwise, all their business is localized within the area. That is why I was telling you earlier, within an area, the topology table will be identical. Don't expect OSPF topology table to be same in area 1 and area 5. No, not possible. But within area 1, every router will have identical database. Within area 5, every router will have identical database. To combine all these areas, you got area 0. Even if I have a connection like this, these two cannot form neighbor. Without area 0, area 2 routes cannot be learnt in area 3. Non-backbone areas can communicate only through a backbone area. There is no chance. Why? They won't even form neighbor. Because they don't form neighbor, no updates are shared. So the route will not be formed in this direction. It will be only via this direction. So OSPF is well designed to accommodate very large network. As I said, the frequent talkers are within an area, so everything is localized. If any change happens in a network, the change will be flooded to everyone in this area, but not to other area. Other area need not to know about that small change that has happened. Why? Because it's not the business. It's local to area 1. The information is local. If someone really wants to go from Y to this X, which is already down, the packet will go all the way down here and then get dropped because this router will say, sorry, X is no more available. That is okay. Very rarely, they don't talk frequently, right? So every area need not to be synchronized. Area 2 will have only the summary of area 1, area 2, Area 2 will have only the summary of area 1 network, area 3 network, area 4 network, area 5 network, area 0. Only the summary. This is another very good reason why why OSPF can accommodate any number of networks. Because you are not going to learn every specific subnets of other area. You are not going to learn every specific subnets of other area. You are going to see only this summary of other area network. So that keeps the updates sent between area small, the routing table small. If your routing table is small, updates are small, the process consumption is going to be also small. When the process consumption is small, you have enough of processor to accommodate more and 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 more networks. OSPF is popular because of these reasons. OSPF calculates the cost based on bandwidth. So the metric of OSPF is called as cost. Now this is auto cost, automatically calculated cost using bandwidth. But if you say no, please don't do that. Let me give you the cost. OSPF says, yes, sir, Roger. So you may use OSPF by configuring cost manually on each link. According to the cost that you have specified, it will do the total cost calculation on each path, and it will decide which one is the best path. Or you can leave it default, which is auto cost. Based on bandwidth, it will calculate. More in depth, we'll be seeing these things in coming days. I'm just giving you overall of OSPF today because it's the first day. So far, we have seen the advantage of having areas. You can localize the impact of topology change within an area, so you don't disturb all other area with the small updates. See, someone lost cell phone in the streets of Bangalore. Is it a real news that need to be told in BBC? No, not at all. Someone lost a cell phone in the streets of Bangalore. Even, it is not interesting news for people in Bangalore, first place. So those news need to be local. Likewise, all the frequent talkers are grouped in areas. So it's unnecessary to flood those news to everyone. OSPF never does it. So we got multiple areas to summarize and send our networks to other area. So we get a summarization point. If you don't have areas, you will not have a border router. If you don't have a border router, you will not know where to summarize. In OSPF, you cannot summarize anywhere that you like. You summarize only in this place, which is between the area. Because within an area, you need an identical topology. You should not summarize on any router within an area. Summarization is only on the border. So you get the border router, it's because of area. Because you do summarization, when a subnet goes down, it is only localized. It will not be sent to others, because to others you have not advertised the network. You have advertised the summary of it. Only all the network goes down, the summary will be pruned back, which is not going to happen. So OSPF is well designed to suit to any size topology. You can also take routes from some other protocol, or it may be another autonomous system OSPF, and redistribute into this OSPF. See, this is one OSPF. You may have another area 0 with many areas. You may have another area 0 with many other areas, say like area 1, another area 1, another area 2, another area 3, connected to another backbone. So that is another OSPF domain. This and that is not same OSPF autonomous system. They are different OSPF. So you can take from that OSPF and redistribute into this OSPF. So this router runs both the OSPF. And we call that router where we redistribute between one OSPF and to the other OSPF, or between one OSPF and EIGRP, OSPF to BGP, OSPF to RAID, OSPF to ISS. We call that router where you do that redistribution from and to OSPF is as ASBR, Autonomous System Border Router. Autonomous System Border Router is the place where the external routes are pumped inside this OSPF. ASBR. So if you want to summarize the external route, which is the best place? This is the best place, ASBR. See how nicely OSPF is designed. Very nicely designed protocol. Well designed. OSPF also supports authentication like BGP. In BGP, if you want to enable authentication, what we do? Router BGP 10 neighbor 1.1.1.1 password, and you type a pre-shared key, Cisco 123, something like that. See, because I did not do this authentication lab, I'm writing the command and showing you. So you put the same password on the other router and they form neighbor. This is an MD5 authentication. BGP supports by default MD5 authentication. OSPF also supports authentication 3 times. One is called null authentication, which means no authentication. Null authentication type 0. Authentication type 1 is the clear text or the plain text. Authentication type 2 is MD5. Right, so we got authentication to authenticate whether the routes coming from neighbor is genuine or given by some spoofed neighbor. OSPF also supports non-broadcast multi-access network types. There are 5 network types of NBMA in OSPF. Non-broadcast, like frame relay cloud, We'll go in depth later. Now, OSPF uses different types of advertisements. We call it as LSE types. Using these LSE types, we can also have different area types in OSPF like stub, totally stub, not so stub area, not so stub area, totally not so stub area. Right? So like this, OSPF is wonderfully designed, highly used, highly scalable, easy to configure protocol. Compared to ISIS, OSPF is definitely easier to configure, but both are link state routing protocol, ISIS and OSPF. Comparatively, this is easier to deploy. So OSPF is more popular. Right, so in coming days, we are going to go deep into what we have discussed in this introduction to OSPF class. Any question?
So all of this is fine. The only thing is I just want to have more clarity on like when is the LSR link state request happen? When does it happen? When does LSR or LSA update sent, or the database DBB? So these terminologies, like where do they actually fit in when the devices start to communicate over OSPF?
Very nice.
That clarity.
Yeah, thank you. So this is in the initial time. They undergo like 7 stages of adjacency, which we will be talking in depth, in which there is a place called exchange state. That is the place where DVDs are exchanged. And then there is a place called loading state. That is the place where LSR and LSU are shared. Now I'll go in deep on these things, and then I'll debug and show you when which packet goes in between the neighbor. Did I answer your question?
Yes,
Yeah, in detail also we'll go again. Thank you. Any other question from anyone else?
Sir, unicast packetன்னு சொன்னீங்களா?
Yeah. Unicast is only when neighbor, after receiving my DBD, if he wants some clarity on something, he sends the LSR as unicast. Because I received from one particular neighbor a query, I reply him back with the same unicast LSU.
Okay.
But sometimes LSU is also multicast. It depends on what type of update I'm sharing. If the update is common for everyone, then it is going to be multicast. If it is for one particular neighbor, then it's going to be unicast.
Okay.
All right.